The journey begins with healthy rubber seeds, selected for a productive, sustainable plantation. Empty, cracked, and diseased seeds are removed to improve germination and seedling strength. Each green rubber capsule has 3 lobes, 3 chambers, and 1 seed per chamber. When mature and dry, the capsule splits into 3 sections and releases its seeds. After absorbing moisture, the root grows downward while the shoot rises and begins photosynthesis. In the nursery, moisture, shade, and nutrients are carefully controlled during early growth. A strong seedling has a firm root collar, straight stem, healthy leaves, and no damage. Growers graft buds from high-yield clones onto strong rootstocks to preserve desirable traits. After successful grafting, the new shoot becomes the main stem and carries the selected genetics. Fine mist irrigation maintains even moisture without saturating the soil and suffocating young roots. During field planting, the root ball stays intact and the root collar remains level with soil. Soil is gently firmed to remove air pockets while allowing continued root expansion. A support stake and loose tie protect the young tree without restricting stem growth. Correct spacing improves sunlight, reduces competition, and supports long-term plantation access. Rubber leaves have exactly 3 leaflets, supplying energy for growth and latex production. Well-planned rows, roads, and drainage improve the efficiency of future plantation work. Before tapping, trees focus on trunk thickening and building bark that can recover repeatedly. Tapping usually begins when the trunk reaches about 50 centimeters in circumference at standard height. Latex vessels lie near the cambium, so deep cuts can damage bark renewal and tree health. Uniform plantations simplify tapping schedules, labor organization, and long-term production control. Early morning tapping often extends latex flow because temperatures are cooler and humidity is higher. Precision is essential, since incorrect cutting depth can harm a tree for years. A tapping knife removes a thin bark layer, unlike a machete that chops with force. A sharp blade creates a clean edge, limits tearing, and reduces unnecessary bark loss. The sloping tapping line guides latex toward the spout, while the lower trunk stays clear. The knife follows the trunk's curve and remains shallow along the existing tapping line. Each pass removes only enough bark to reopen latex vessels without reaching the cambium. Latex seeps as a cool, milky liquid and never produces smoke. It follows the sloping cut, vertical channel, and spout in one gravity-fed path. Because latex is viscous, it usually forms droplets instead of spraying under pressure. Clean, stable, correctly positioned cups help protect raw latex quality from the start. Skilled tappers work efficiently, but bark protection must always come before speed. Block-based schedules control tapping frequency, prevent over-tapping, and allow proper recovery. Collected latex is gathered before rain or natural coagulation can reduce its quality. Gentle handling limits bubbles, spills, and bark fragments in the fresh latex. A shoulder yoke balances 2 containers, making plantation transport safer and more stable. When latex is combined, every cup, bucket, and tank affects the entire batch. Density and dry rubber content are checked to estimate concentration and batch quality. Fast transport shortens field exposure and reduces the risk of premature coagulation. Sealed tankers protect latex from dust, rain, microbes, and uncontrolled batch mixing. At the factory, each shipment is tested for concentration, stability, and mattress suitability. Gentle agitation keeps rubber particles evenly dispersed without creating excessive foam. Multi-stage filtration removes bark, solid debris, and impurities before centrifugation. Centrifugal force removes part of the water and increases the rubber concentration. The water-rich serum is separated while concentrated latex moves to controlled storage. Closed tanks and stable temperatures preserve uniformity before the foaming stage. Flow, pressure, and processing time are controlled for consistent density and elasticity. Sanitary closed pipelines reduce exposure to air, dust, and cross-contamination. Before foaming, the laboratory confirms latex stability, viscosity, and formulation. Approved latex enters the Dunlop process and begins forming the mattress core. Air is dispersed into tiny bubbles, creating the foam's cellular structure and recovery. An open cell network improves airflow and allows fast recovery after compression. Foam must fill the mold evenly to prevent overly soft, firm, or dense areas. Metal mold pins create ventilation holes and can form different support zones. After filling, the mold is sealed to preserve shape during vulcanization. Steam heats the mold, linking rubber molecules into a durable, elastic network. Precise temperature and curing time determine durability, elasticity, and structural uniformity. Multiple molds increase output, but each batch still requires separate monitoring. When opened, the mold releases a stable core with its shape and ventilation pattern fixed. Fast shape recovery after compression is a key property of vulcanized natural latex. The fresh core remains soft and water-heavy, so it needs even support to avoid distortion. Repeated washing removes residual additives and soluble substances after vulcanization. Compression rollers extract water while protecting the foam's internal cellular structure. Even warm air drying prevents retained moisture from affecting odor, hygiene, and durability. Natural latex is usually light ivory and does not need to appear plastic white. After drying, surfaces are inspected for tears, uneven cells, size errors, and defects. The surface feels gentle, while deeper elastic resistance provides continuing body support. CNC trimming standardizes dimensions and edges for an accurate fit inside the cover. Compression and height tests measure fatigue resistance and recovery after sustained loading. The breathable, durable cover protects the core and manages direct body contact. During assembly, correct core orientation preserves dimensions and ventilation patterns. Compression packaging reduces shipping volume without exceeding safe recovery limits. During delivery, the mattress is protected from folding, impact, and prolonged point loads. In use, natural latex distributes pressure and quickly recovers as the sleeper moves. Its value comes from continuous quality control, From selected seed to finished mattress,